After we have learned about neurons and neuronal communication, we are moving to the new topic on sensation and perception. Sensation plays a role in helping us explore the environment around us, and perception is the process of understanding this information and directing our actions and behaviors. Sensation and perception are two distinct terms. There is a difference between them. Sensation is the physical experience of a sensory stimulation, such as hearing a rhythm. And then during sensation, we will engage in transduction. This is to convert the stimulation to signals and then being processed by the brain. And then finally, perception is a psychological process. So you might want to interpret what rhythm you are hearing. So for me, during my undergraduate studies, the best hip music playlist on YouTube was Thank You Next by Ariana Grande. And now it seems like Rosé's new song called APT. Not all senses are pleasant, so you might wonder, why do we need to experience them? So senses can provide us environmental cues. So we may smell food to know where we could get a recharge, and it's important for our survival. And we may avoid eating foods that may make us sick. And then we may wear a hand glove to avoid our hands getting frozen during winter. So these different senses are important in helping us survive. Sensation starts by stimulus detection. Researchers examine our ability to detect a stimulus by thresholds. So absolute threshold is the minimal intensity to detect a stimulus. And it's a difference between sensing or not. So if a person can detect a stimulus for around half of the time, we will define this as absolute threshold. In class, I played a sound and asked you to raise your hand when you hear something. And at the moment you raise your hand, this is an example of an absolute threshold. A person's absolute threshold may vary by person or context. For example, in older adults, hearing decline may take longer to hear that sound. Or if in the classroom it was noisy, it may also influence our ability to detect a stimulus. The 5 major senses are vision, audition, touch, taste, and smell. This picture shows the absolute thresholds for the different senses. You may want to direct your attention to the taste one, so people can actually taste sweetness when adding a teaspoon of sugar into 7.5 liters of water. So think about this when determining the sweetness levels when you order your drink next time. Do you really need to drink that sweet? Or can you potentially cut down some sugar and then you can still taste sweetness? When we measure absolute thresholds, we usually focus on signal detection. It is to study whether or not a person can detect a signal in a sensory modality. So in the study, a signal may be presented and the participants will be asked to give a response. So for hit, it is when we presented a signal and the participant gave a response. And for false alarm, it's when a signal is not presented, but the participants say it was present. And for miss, it is when a signal was presented, but participant did not give a response. And finally, for correct rejection, it is when a signal is not presented and the participant also did not give a response. What we have just covered is when there is only one stimuli involved. But in reality, there may be more than one stimuli involved and each with different threshold. So the concept of differential threshold is to be able to detect the difference between 2 stimuli, each with different thresholds. And we will use the term just noticeable difference to depict this change. So it's the smallest amount that something needs to change for the difference to be detected. And this will depend on the stimulus intensity. So think about this example. When you keep your cell phone brightness at the same level, are you more likely to detect a change in light when you are in the dark or in the sun? So the answer should be you are more likely to detect when you are in the dark. So we will say this as the just noticeable difference being small in the dark. And another example is if I have black hair and then I dye my hair to dark brown. So the just noticeable difference needs to be bigger because my hair is already dark. But if I dye my hair to blonde, the just noticeable difference will be small because you will suddenly realize that I changed my hair color. Here is another example. So deep-fried sweet potato bowls is a famous Taiwanese snack. So look at the pricing. So for the large pack, you may get 15 bowls, but one day is shrink to 12 bowls per pack. And for the small pack, originally you will get 8 bowls, but one day is shrink to 5 bowls. So the ability for you to detect a difference is small for the small pack. So 8 bowls suddenly shrink to 5, and then we will say this, the just noticeable difference is small for the small pack. The Weber's law states that to perceive a difference in two stimuli, they must differ by a certain degree and percentage. So for weight, to detect a difference in weight change, you must differ by 2 to 3% of your original weight. So if you worry too much that you are gaining weight during Chinese New Year, your weight needs to increase by a certain degree for someone to say that you have gained weight. After talking about signal detection, we will now talk about perceptions. Our perceptions are built by two types of processing, the bottom-up and the top-down. So the bottom-up one are built from raw sensory input. So you may see the picture with 2 vertical lines and 3 horizontal lines. And for top-down, you may utilize your experience and knowledge to interpret the image. So based on your previous knowledge, you may see the figure as a letter B, or the number 13, or the Chinese character zhi. To illustrate the concept of sensory adaptation, let me share a small story with you. When I was in university, there is a Subway store beside the lecture hall for my general psychology class. At the first lecture, I think the smell of the bread is quite strong, and I can even smell it in the classroom. Towards the end of the semester, I became less sensitive to that bread smell. So it illustrates that our sensitivity to the stimulation tends to decline over time. There are many factors that can affect our sensation and perception. The first one is selective attention. So in class, I played a video and asked you to count the number of basketball passes among those who wore white. And then around half of the students didn't see the black gorilla pass by because you focused your attention on counting the white passes. Based on the signal detection theory, another factor that may affect our sensation and perception is our motivation and current mental state. For example, if a mother has a motivation to be alert to her baby's needs, she may be awakened by a quiet murmur from her baby, but not by other sounds. An attentional blindness is a concept similar to selective attention. You may fail to perceive unexpected stimuli when they are not the focus. But when there are shared features with the focus, you are more likely to detect it. In the gorilla video, you were asked to count passes in white, and there was a black gorilla. But in fact, if the gorilla was in white, because it has shared features with the counting passes in white, you are more likely to detect the gorilla. In addition to visual blindness, there are auditory distractions can also induce an attentional blindness, such as using your cell phone while you are driving. Efforts can be made to reduce an attentional blindness. The first one is to just simply avoid different distractions. So maybe turn off your cell phone while driving. The second way is to avoid multitasking. Research has found that people who multitask perform poor on cognitive control. So this may include difficulties in task switching or inhibiting different behaviors and thoughts. And finally, pay extra attention to what others might not see. So be aware of the blind spots while you are walking or driving. Apart from attention and motivation, there are other factors that may influence our sensation and perception. For example, the life experience of having binocular dysfunction may impair a person's ability to perceive depth. Binocular vision is when our two eyes are located in different locations. So we are able to see things in different angles, and we can see 3D images and also depth. But if a person has binocular vision dysfunction, their eyes will be misaligned and they cannot perceive depth. Culture is another factor that may influence our sensation and perception. The molar-layer illusion is when some people are more likely to think that the middle line is longer, but in fact, all lines are in the same length. And finally, values, prejudice, and expectations may also influence our sensation and perception. So people who have positive attitudes about healthy food may think that healthy food actually tastes better. We will end the introductory video on sensation and perception here. In the next video, we will talk about vision.